I mean, the Bitcoin design is beautiful. We just tweak it a little, and then like scaling becomes obvious. So I read about blockchain before, and to be honest, I initially thought it was a scam back in like 2014. But then my advisor, he just randomly tells me, hey, I'm taking a sabbatical. And I'm like, oh, are you trying something big? He's like, no, I'm just going to stay in my garage and work on blockchain problems. And because I trust my advisor, I was like, oh, can I also do that? And he's like, sure, like my garage can fit too. And that's when we started working, and I just thought I'll work on it for 3 months just as like a pure experiment. But it turns out that like blockchain is like a fundamental technology. To use Peter Thiel's word, it's like a 0 to 1 technology. That is, it's doing something which couldn't be done before. It's like, just imagine internet, right? Internet has so many different components. You have a lot of people. They're connected via these fibers. And you have to design protocols on how they communicate with each other. And once these protocols are scalable, you can start building emails. Then you start building simple, I don't know, like web pages. Then you start building like Amazon. And then today we are ordering groceries and doing our laundry on the internet, right? So it's like building this whole system. And blockchain also has like many parties talking to each other. And it's more of a network effect. That is, each time a new person comes into this, joins this network, the marginal benefit of this person increases, and the network as a whole gains. It's like a social network. And that's the reason you have to design the system to scale. Fundamentally, it's about reaching consensus, right? So today, like if you just take the Bitcoin ledger, the whole world has agreed on who owns how much Bitcoin without a central party telling you that. So this is the first time where people have reached consensus on internet without a central party. Once you reach consensus on something with this high security, then you can start using it for transferring value. The fact that Bitcoin was used to transfer value shows you how strong the technology was. It's like, imagine internet started in like 1990 and people started doing payments over internet, right? Maybe that was not the first application. So Bitcoin, it has very high security, but unfortunately the performance is poor. That is, it can only support 5 to 7 transactions per second, and it has a very high settlement time. That is, if I pay you 1 Bitcoin, it's not instantaneous like swiping a Visa or MasterCard. What we've been working on is, how do you fundamentally design a blockchain which can support say thousands to 100,000s of transactions per second, ideally, and reduce the settlement time to under a minute. In Bitcoin, at a high level, every 10 minutes, a person wins a lottery, and he says or she says, hey, let's include these new transactions on the ledger. And then some time is like, after that, people start voting for that the legitimacy of that block. So you have a stage of proposing, and then you have a stage of leader election, that is, this person wins the lottery, and then you have voting. And currently in Bitcoin, the way it is done is you have a block every 10 minutes, and the first block, which includes a transaction, is playing the role of leader election, and all the blocks which are pointing towards that are voting on this block. But because these two roles are coupled, the blockchain has to grow very slowly, because if you grow it any faster, there will be a lot of confusion in the system, because the world, like, there is this network latency. So people will start seeing different views of the blockchain, and there might be a lot of inconsistencies, and that reduces the security. So what we do is we just decouple these two roles. We decouple the voting from the leader election. And the leader election has to be slow, but there is no reason voting has to be slow. And then we scale the voting. And this actually gives us very high, very low latency. And then we decouple leader election with adding transactions in the system. And that next step of decoupling gives us high throughput. I think so one of the next biggest applications of blockchain is in the financial industry. Because all of us own dollars, but we also own stocks, bonds, our retirement savings, and there are a lot of derivatives which move around in the financial industry, and all of this could be imported on a blockchain.